Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Maximum XOR for each query, Leetcode 1829. In this problem, we are given sorted array nums of n non-negative integers and an integer maximum bit. Now, we should perform following query n times. 1. Find a non-negative integer k which is less than 2 to the power of maximum bit such that XOR of num0, nums1 all the way up till last element in the array and k itself is maximized and k will be the answer of this query. Then we remove the last element from the current array and start the same operation. And in the end, we will return an answer array where answer I is the answer of the ith query. Then in example 1, for the given input array and maximum bit equal to 2, output is 0323. Let's see why. Now because maximum bit is equal to 2, maximum value of k is less than 2 to the power of maximum bit, that is 2 square. So k can be in the range 0 to 3. Not just k is less than 2 to the power of maximum bit, even the numbers in the array are greater than equal to 0 and less than 2 to the power of maximum bit. I think this is a very important constraint and generally we don't read the constraints, but in this problem it is super important. And what does 2 to the power of maximum bit means here? When we read the binary number from least significant bit to most significant bit, this is the 0th position. And when we are doing 2 to the power of 2, then this first bit will be set. If we are doing 2 to the power of 3, then we will get 8 and this second bit will be set. If it was 2 to the power of 4, then third bit will be set and so on. So when we are doing 2 to the power of 2 minus 1, we will get 1 1. Similarly, when we do 1 0 0 minus 1, we will get 1 1 1. So the maximum possible value when we do the XOR between these numbers is when all the bits in the number are set, and that will be our maximum value. So for example, in this case that maximum value is 3. If maximum bit was 3, then that maximum value will be equal to 7 because in that case there are all the bits set. As all the numbers are in the range 0 to 2 to the power of maximum bit minus 1. And we know that if we do the XOR between two numbers, the bits may flip. If bits in the number at a particular position are different, the resulting bit after performing the XOR operation will be 1. But if they are same, the resulting bit will be 0. And the maximum value can only be achieved when all the bits are set. Now coming back to our example, what is the maximum XOR value for the given array? It will be 3 because maximum bit given to us is 2 and the maximum value can lie between the range 0 to 2 to the power of maximum bit, and if we perform the XOR operation between them and in the output all the bits are set, we will get the maximum value, and in that case it will be 3. And our job is to maximize the XOR between the numbers as well as the chosen k, which will be our output. So for the first query, we will perform XOR between 0, 1, 1 and 3. So 1 XOR 1 will cancel each other out and 0 XOR 3 will be equal to 3, which is equal to the maximum value, which will have all the bits set, that is 1, 1. So what should be the value of k? Because we have already achieved the maximum XOR value, we want k such that 3 XOR k is equal to maximum value, that is 3, and for that k comes out to be 0. Because now if we perform the XOR between them, we will get 3 again, which is our maximum value. So k for the first query will be equal to 0. Then for the next query, we remove 3. So we will just take the XOR between 0, 1, 1, which is equal to 0, as 1 and 1 cancel each other out. So because now none of the bits between the XOR values in the array are set, what is the maximum value we can achieve? That is 3. So we want k XOR 0 equal to 3, and that's why k will be equal to 3, as 0 XOR 3 is equal to 3. Then for next query, we will remove this 1 as well. So we will get 0 XOR 1, which will be equal to 1. And now we have to do 1 XOR k such that value is equal to 3. And again, how will we do that? To achieve the maximum result when XORing the numbers a and b, the other number must have opposite bits in positions to ensure that all the bits are set. because when we perform the bitwise XOR operation, if the bits are same, the result is 0, but if the bits are different, the resulting bit is 1. So how about to find the value of k, we perform XOR operation between maximum number, in this case 3, and array XOR we have achieved so far, which is equal to 1, that is 0, 1 in this case. So if we perform the XOR between them, we will get k as 1, 0, that is 2, which is complement of array XOR we have achieved so far. So now if we do 1 XOR 2, we will get 3, which is the maximum value. So we will use 2 to the power of maximum bit minus 1 as a bit mask in a way to get the value of k. And now finally let's look at the last example. So again, only number we have for XORing is 0. K will be equal to 0 XOR 3, which is equal to 3. Because now when we do 0 XOR k, that is 3, we will get 3, which is the maximum value. I hope this example was clear and we are kind of now developing the solution sense as well. But let's look at more examples and go deeper into the solution space. Now let's say maximum bit is equal to 3. Then each element in the nums array lies within the range 0 to 2 to the power of maximum bit minus 1, that is 0, 7. Also, after XORing all the elements, the resulting value, let's call it num XOR, will also fall within this range. So to maximize the XOR result, we need to find k such that num XOR k is equal to maximum value, that is 7. So now let's take some cases. Let's say num XOR is equal to 0. Then to maximize the result, k should be equal to 7 because 0 XOR 7 is equal to 7. Similarly, if num XOR was equal to 1, k should be 6 because 1 XOR 6 is equal to 7. Similarly, if num XOR is equal to 2, k should be 5 because 2 XOR 5 is equal to 7. Similarly, if num XOR is equal to 3, then k should be equal to 4 because 3 XOR 4 is equal to 7. So basically, as we already saw, k's value can be derived from num XOR and it will be equal to 7 XOR num XOR itself, where 7 is the maximum value of k. And now the question is, how can we get num XOR? And there the idea is simple. We can actually take the XOR between all the numbers in the array, which we anyways require for the 0th query. And then for first query, we have to XOR between all the elements except the last one. So how can we get rid of the last element? By XORing the last element with the num XOR itself, because then the last element will cancel out, because XORing an element twice cancels it out. Similarly, for the second query, we will remove the second last element as well. So now we will XOR the num XOR with second last element. So that's how we will continue. And finally, when we are done with all the queries, we will return our answer. Now let's jump into the code part. First, let's create num XOR to store cumulative XOR of all elements in an array. Initially, it will be equal to 0. Now we will iterate through the nums array and calculate this cumulative XOR. Let's also create answer array of size n to store all the answers, and max k to store maximum value of k, which will be 2 to the power of maximum bit minus 1. And for getting 2 to the power of maximum bit, we can do 1 left shift maximum bit, or we can use math.pow utility in math library to do the same. And now we will start filling in the answers, that is k, and ith answer will be equal to XOR of cumulative XOR of array and maximum k. And now we will remove ith element from the AND from this num XOR. And how can we do that? We will just take its XOR with num XOR so that it cancels out. And once we are done with this loop, we will return our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the number of elements in the nums array. Because first we are iterating through this nums array and calculating the cumulative XOR. And then again we are filling in this answer array with n answers. And in terms of space complexity, additional space complexity is O of 1, because we anyways need this answer array to store n answers, which will take O of n space. But other than that, we are using some variables here and there. And now the question is, what was the use of array being sorted in this problem? And the answer is, I don't know. At least to me, it looks like it was useless. But you can share your thoughts in the comments below. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.